Hello everybody and welcome back. So in this video I'm going to be challenging you to try to understand and write code in the most convoluted language I've ever used, which I'm going to call, for the purpose of this being a family channel, Brain. Now I know you all know the name of this language and you can probably assume why it's so complicated and why it is named after that. And on the left side of my screen here you can actually see that this is an example of a program written in, again, what I'm going to call Brain. Now if I go ahead and run this code, we can see this actually prints hello world. So if you're interested in seeing how this works, why this works, and learning a little bit about how you can write code in Brain, then follow along and be showing you how to set this up, what these basic commands do, and then we're going to walk through how we can actually go ahead and create this hello world program. Okay, so I want to start with a very brief overview of this language, and then we'll actually get into a few examples and talk about exactly how it works with all of these key characters, which we can see here. So this language is extremely small. It consists of 8 key commands, and those are the only things that you can use. These are the commands here. You can read them if you want, although we will go over them in a second. And this language is actually designed to be able to run on very, very small interpreters or compilers. In fact, the record compiler for this language that has been written is actually only 100 bytes itself, which is extremely small. So what I'm going to do now is hop over to the whiteboard, and I'm going to explain exactly how this language works with a few visual examples. Okay, so I need to start with some fundamental concepts here to make sure everyone's on the same page, and I'm just going to explain what a bit and what a byte is, because we need to know that to be able to deal with Brain. So a bit is either a 0 or a 1. This is what we call a bit. So one of these two things is a bit. So that means if we have, say, 2 zeros here, this is 2 bits. Now, I'm sure some of you have seen binary before. I'm not going to really explain what binary is or the binary numbering system, but 1 byte is consistent of 8 bits. So we can have this here. So that's 4, 2, 3, 4. And the way that we actually figure out what numbers are when we're looking at bits is we say the first bit is equivalent to 2 to the 0. The second bit is equivalent to 2 to the 1, then 2 to the 2, then 2 to the 3, 4, ... until 2 to the 7. Which means that, say we put a 1 here and the rest are zeros, all we do is multiply, in this case 2 to the 3 by 1. What is 2 to the 3? That's 8. That means this down here represents 8 in our decimal numbering system. That's as much as I'm going to explain for the binary digits, but just understand that that's what a bit is, and a byte is consistent of 8 bits, and well, a byte tells us a value between 0 and 255. So if we have 1 bit, since we start at 0 here, right, so 2 to the 0, and we go to 2 to the 7, well, 2 to the 7 is 128, but since we can represent all the other combination of numbers, we can actually represent, 2 to the 8 minus 1 combinations of numbers, which is equal to 255. You ever see an RGB pixel? Guess what? That's consistent of 3 bytes because we have red, green, blue, all those values between 0 and 255. And each byte can represent between 0 and 255. Again, why you need 3 bytes to represent an RGB pixel. So that's the basis of bytes and bits. Hopefully that makes sense. And now we'll move on to the next component, which is the actual language itself and what we call the memory block. So I'm going fast here, but that's just because I assume most of you already know this. So this is what we call the memory block, and this is the most fundamental thing to understand in our Brain programs. So our memory block is made up of a certain amount of space, and this space is pretty much where we're allowed to store values. It's where we're allowed to take values, add values, manipulate values, and each one of these little slots that I've drawn here is 1 byte. Now remember, a byte is simply made up of 8 bits, which means one of these slots can represent a value between 0 and 255. And all of these little slots are what we're going to think of as almost like our little variables, right? They're not really variables, but you can think of them like that, and they're what we need to reference in our program. So we could say that this is slot 0, this is slot 1, this is slot 2, all the way until we get to slot at some value, which in this case I'm going to say 2 to the 16. So for our program, we're going to use 2 to the 16 slots. So we're going to use a memory size of 2 to the 16. What that means is that we actually have 65,300 something slots, which is not even 1 megabyte. So just keep that in mind. We have a very small amount of memory that we're working with. And that's one of the advantages of this program, is that you need a very small amount of memory to actually do things. So that's what we have. We have this memory block. Each slot has a byte in it, so that's 8 bits. That's a value between 0 and 255. If you needed to represent a number larger than that, you would have to use more than 1 slot. So that's the way this works. And this actually compares a lot to some lower level computing. And any of you that would have done like a computer architecture class probably have a really good idea what I'm talking about right now, because you probably learned that in that class, assuming you were paying attention. So all these slots start off at the value 0. That's something to understand. And all of these are just initialized at 0. 0 for us means null. It means there's nothing there, or, the number 0. Now, the next thing we need to talk about is a pointer. So since we have this memory block, we need to have some way of accessing these different values. So how do I change, memory block 2 to the 16, or how do I change memory block 2? Well, I do that using the pointer. So the pointer, which I've written here, which is PTR, simply tells us what memory block we're at right now. So the pointer is going to store a value between 0 and 2 to the 16, right? Because that's going to tell us the number representing which memory block we should be modifying or we should be changing. So that's something to understand. That's what the pointer does. The pointer is some numeric value between 0 and 2 to the 16. So now I'm going to show you the main commands in Brain. So what we need to do essentially is manipulate the pointer and manipulate the values in these cells to get some output that we want. So remember that in these cells, these values are between 0 and 255. And the goal of our program here when we start writing is going to be to print hello world. So how the heck am I supposed to get a character when the only things that I have in these cells are numbers? Well, this is where we talk about something called ASCII. So ASCII, I actually forget exactly what it stands for, is essentially a way of using integers to encode or represent some character. So I don't know all the ASCII values off by heart. I'm going to show us an ASCII table later that tells us what this is, but essentially the basics is, let's say the number 65 actually represents the capital letter A. So that would mean 66 represents B. And then if you add, 26 to that and then add 1, that would be the lowercase letter a. And these are kind of the characters that we need to use. If you want to do an exclamation point, you'd have to look up what that value is in ASCII to see what it is. But the idea here is if we want to print something out, we have to change the value inside of our slot to be equal to the ASCII value of the character that we want to show. So if I wanted to show capital A, I would need to change one of the values inside of my slots here to be 65 and then print out the value of this slot, and it would be converted to the ASCII value and it would show that for us. So that's the basics with ASCII. Hopefully that makes sense. Look up an ASCII table if you want. I'll show one in a second, but it's pretty easy to understand. It's nothing too complicated. Okay, so here are the commands. Again, we want to print hello world. I'm not going to show this example exactly here. The first command is move the pointer left. So this less than sign here that I've just circled means move the pointer left. I mean, you could call it greater than if you want. So essentially, if we're at 0, which where the pointer starts, it always starts at memory location 0, so the pointer starts at 0, what we would do is actually circle this pointer back and go to the very end of our memory block, which would be at the location 2 to the 16. So if we did that, we would go all the way to the back, right? Now, if our pointer was here at memory location 1, then we would simply move the pointer back 1, right? So we would go boom here, and then it would be at location 0. So again, the goal of the pointer is to just tell us where we are. It's our way of navigating around. And then you can assume that if that moves us back, this command here moves us forward. So this moves back, this moves forward. So this goes to the right like that. So our pointer would go here. And again, if we had our pointer here and we executed that go right command, what would happen is we would loop all the way back and we would go to the very beginning and be at memory location 0. So that's the basics between navigating the pointer. Hopefully that makes sense. You can use those less than and greater than signs to go, right, left, right, left, right, left, however you want. So now that we know that, we can talk about how do we actually change the values at some memory cell. So since we can navigate this pointer and move it around, we can get to whatever cell we want just by moving a certain amount of times. So doing this command a certain amount of times, right? If we want to move over 5, we write it 5, right? That's the basics. If we want to modify the cell, we can use the plus, which stands for increment, or the minus, which stands for decrement. So to put it in programmer terms, the plus is plus equals 1, the minus is minus equals 1. If you're in another language, that's going to be like plus plus or minus minus. So when we execute the plus command, what happens is whatever location we're currently at, 1, the value 1 gets added to it. So we go like that. Right? If we did plus twice, so say my code over here, like this is the code that I'm executing, then what would happen is this value we would change to be 2. And let's say we did something like plus minus, so we execute this code, then what would happen is, well, we would stay the same because we added and then we subtracted, right? So that's the basics of the plus, the increment, decrement. Pretty straightforward. So that's kind of the idea here, is like if you want to represent, say, the character H, then you somehow have to change this value in this block here, whatever block you want to represent the character H, to be 65, and then print out the value of that block, which I'm going to show you how to do with this next command. So let's erase some stuff. Let's get this cleaned up, and then I'll show you the rest. Okay, so the next command to talk about is the period. Now the period stands for print byte. Now what that means is whatever the byte is at the current pointer, right? So we've navigated the pointer to where we want it to be, and then we call this plus like this. It will output the ASCII value associated with the number at that location. So I don't know what the ASCII value is for 2, but let's say we had that classic example of 65. If we printed when our pointer was at 65, so let's just assume, you know, like this is our memory block, maybe location 1, our pointer's here, then we would print out the capital character A. The next command that we need to look at is the comma. So the comma actually is input byte. So input byte like this. It's going to take in some byte. It's going to convert that byte. So this is going to be a character, right? It's going to take in, you know, some letter, going to convert it to its numeric value, and it's going to store it in whatever location we're currently at. And it will override anything that's already there. So let's erase this. So if our pointer is at memory location 0, which we can see because that's where it is, then if we call the comma, we'll actually wait for the user to type something in. So let's say I type A. Then what will happen is wherever our pointer is, we will change what's in this location to be the integer value represented with that character. In this case, it's going to be 65, right? And those are the basic commands. Now we're going to talk about looping, which is a little bit more complicated, but you should hopefully understand that if you've understood everything up until this point. So to loop, we have our last 2 commands, which are open loop and close loop. So this is open and this is close, like that. Now what we put in here will happen a set amount of times. Now it's better for me to explain this when we actually write the code, so I'll kind of refrain from going too far into it. But whenever you open a bracket, you must close it somewhere. Just like if you open a squiggly bracket in Java, you have to close it somewhere, unless you're doing something crazy that I just don't know about in Java. But the point is, right, is that the way these work is if at the current pointer location, the value is 0. So if we, you know, actually I'll leave that at 65 for now. But if when we encounter this sign, so let's say our code is like, you know, plus, so we're going to increment that. I want to change this actually to be a better example. Let's put this at 2. So let's say plus is our current code. So we'll write code like that. So our pointer started at 0, we changed it to 2. And then we encountered this open, which meant start loop. What would happen is we would check what our value is at the current pointer location, and if it was non-zero, we would enter the loop. If it was 0, what we would do is we would jump to wherever this close is like this. Now I'll talk about why that works in a minute, but understand that if wherever the current pointer value is that we're at is non-zero, so anything other than 0, we'll enter into whatever's inside of this set of brackets. If it is 0, we're going to jump to wherever the ending loop is. So we would jump to here and we would execute the next command. That's how that works. So if in here I had, say, plus like that, and then I put, actually, I need to make this a little bit. Okay, we're going to do plus, go back, minus, and then I'm actually going to go forward in here. So this is going to be our code, and we're going to illustrate how this works. We have plus, we increment that to 2. We come here, since the current value is not 0, we enter the loop, and then we move our pointer to the right 1. So we move it to the right, which we'll do like that. So we'll go here, and we have PTR now here. Then we're going to plus, which means what we're going to do is add 1 to this. So this becomes 1. Then what we're going to do is move the pointer back. So let's move the pointer back. So what that means is we're now going to be at 2. So let's do that. So we go to 2, and then here we have the minus sign, so we decrement at 2. So let's do that. Hopefully you guys are understanding what's happening here. So we decrement at 2, and then what we do is we reach this, and what this says is this is the end of the loop. If the value at our current pointer is non-zero, jump to the start of the loop. If it is 0, go to the next command. That's what that says. So since the value at our current pointer is 1, we're going to jump into the loop again, which means the first thing we're going to do is move right. So we move our pointer to the right. Then we're going to add 1. So what we're going to do is we're going to take this and we're going to go here and we're going to add 1. Then we're going to move our pointer back to the left. So we move our pointer, Then we're going to change this to be 0 because we're going to decrement. Then what's going to happen is when we hit this here, we're going to check if the value at our pointer is 0. Since it is, we're going to go to the next command. So we'll go to the next command, whatever is past the end of this loop here. And that is how the loop works. So you can see what you need to do when you make a loop is have some memory address keep track of how many times you want to loop. So you set it to what you want to loop at, and then you decrement that memory address so that when that memory address gets to 0, you stop looping. And you can see here, all I did was transfer the value from this block here to this block using a loop. Now let's get into the fun stuff, which is actually writing the code. Okay, so what I have in front of me here, as I promised probably like 12 times, is the ASCII table. So this is what I'm going to recommend you have beside you when you program in Brain. Just maybe open another window or something so that you know what values you actually need to make. But you can see that, like I was saying, the decimal 65, I know it's kind of small, but I'll zoom in a little bit, is representing the character A, and the decimal 97 is representing the lowercase character a. Notice there is a difference, and if you want to look up any character on your keyboard, actually, I'm pretty sure any character on your keyboard, you can do that by just looking for the number and looking for the character, and that's the mapping, right? And then that's pretty much all you need to know. Once you know these characters, or you can reference this ASCII table and understand what it's saying, you can generate any character you want. Just notice, though, that it's kind of counterintuitive. 48 actually represents 0, 49 is 1. So don't think that because you have a 0 there, that means you're actually going to output the number 0. In fact, that's going to output null, which means nothing. Now, if you see some crazy ones like this, like FS, US, RS, don't worry about them. You probably don't need to use them. You're only really going to use stuff past 32 when we're in this program. Okay, so now how the heck do we actually run this code? Well, this is going to seem really counterintuitive. I know a lot of you are probably going to be upset by this because we're not downloading like a Brain program, but we're going to use a Python interpreter to interpret and run our Brain code. Now, a challenge to any of you that might think you're a little bit more expert, if you understand how the language works and what I just described, you should be able to write your own interpreter for this. Now, you know, okay, if you're not that good of a programmer, maybe not, or you're not that experienced, fair enough, it's not that easy, but I just found one online. I looked at the code, it's pretty easy. I made my own version, but we're going to use this guy because it's a little bit more robust, but you could write your interpreter for Brain in any language that you want. An interpreter is just something that's going to translate our code into something the computer can understand, rather than, you know, trying to make a compiler or something crazy or finding something online that's really complicated. I figured Python's the easiest way. So if you want to use this, you're going to have to download Python. You can get that by just downloading Python. You know, go to download Python, download the version, and then you're going to download this repository, and there's a link in the description to where this is. Now, I already have it downloaded, so I'm not going to do that, but to download, you can click on clone or download the zip folder, and it'll give you a little folder that has, you know, the Brain name, you can see here, in it, where you'll be able to access the interpreter. So inside here, it says the name of the file, so brain.py, and inside of here, you can actually read through and see how small this is. This is all of the code that's going to be used to actually run your code. So it's going to, you know, there's a function evaluate, which essentially this evaluates all of your code, and you can see we have cells, code pointer, and cell pointer, which is just telling us all of these different things that we need to know to do looping, to be able to store the value. And you can see it's pretty small, it's pretty trivial. And again, I think I said this, but the smallest compiler ever made for Brain was only 100 bytes long, which is pretty impressive. So we come here, we do actually need this getch.py file if you want to be able to get user input. So if you're just going to download one file, make sure you download getch as well. And you can see this is an example of the usage of it. So you do / the name of the script, and then your actual .bf file, which stands for, you know what that stands for, the BF extension. So you can see here that I've already got this folder. I renamed mine with a capital B, but you know, you can do whatever you want. And inside here, this is the same interpreter that I just showed you from that repo. So what you need to do is inside the same folder, you're going to make a file and you're going to call it whatever you want .bf. It's important you have BF. I'm pretty sure this actually checks to make sure the extension ends in BF. Actually possibly not, but regardless. And if you have .bf, then you can run this BF code. So to actually do this, because I know some of you might not understand, you're going to need to get into the current directory where this interpreter is in your command prompt. Now to change directories in here, you can do cd, and you can kind of cd around into the name of the folders. But an easy way for any of you that are beginners and don't understand how to do that is to just find where this folder is on your computer. So I'm going to try to find it. Yeah, there it is. And then in this little bar here, if you're on Windows, it's going to be different on Mac. You're going to have to open the terminal in this folder. You're going to type CMD, and that'll actually open up a command prompt that's in the same folder as where you are. So if you want, you can do that. I mean, I'm already in it here, and you can see you're in the right directory if the path on the left side here matches where your file actually is. And then again, to use this, there's two different ways. You can do / and then the name of the interpreter, which is this, and then the name of the file, which in this case is .testbf. It's not recognized. That's on Linux, sorry. So for us, what we're going to do is go Python. We're going to do the name of the interpreter, which is that. And then you should notice that if I do test.bf, I know it's cutting out, but we'll go full screen here, and I run this, everything works fine. But since I don't have any commands in there, nothing's happening. So that's how you use this. You have to write Python. If you're on Mac or Linux, you're probably going to have to type Python 3 space the name of the interpreter when you're in that folder, and then the name of the file that you want to run. So we've got that working now. So let's actually start writing some code. I know we've gotten a while to get here, but we just had to understand how the language works. So let's clear that, the CLS. And now let's do a very basic script where we just add 2 to our original pointer and print that out. So let's go 2, and then let's do a period. And we know that, you know, the 2 plus signs, that's increment, increment. So our current value at memory cell 0 should be 2. Print, we should print out whatever the ASCII value for 2 is. So if we do that, we get a question mark because it doesn't know how to represent that in the console, right? But let's just go ahead and spam like a bunch of pluses and see if we can get something meaningful. So let's do that. And here we get the character L. So that's the basics on how you do something and then how you print it out, right? Pretty straightforward. So you can see if I go, plus, minus like that, and then I run this, we get nothing because the first character is null. So let's do a little bit of a more advanced example now. So let's say that I actually want to generate the character A, right? So 65. But I really don't want to do like 65 plus signs. Like that's not the best way to do this. What I should really do is use a loop. So what I'm actually going to do is I'm going to set the first memory block to be the amount of times that I want to loop. Now in this case, what I'm going to do is figure out what multiples of numbers I could use to get to 65 faster than having to write 65. So in this case, right, and this is why this is a challenging language because you have to do something like this, what I want to do is multiply 5 13 times. So if I can multiply 5 13 times, then what that's going to allow me to do is get to the value 65, right? So I'm going to set up a loop that's going to happen 5 times, and in that loop, I'm going to add 13 to a memory location, or I'm going to add 1 to a memory location 13 times. Since that loop runs 5 times, we should get the value 65, and I'll show you what I mean by this. So this is my command for loop. We're going to go a little bit smaller here just so it's a bit easier to see. We have 5 plus signs like that, and then here I'm going to do 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now the first thing I need to do is make sure that when I enter this loop, I increment the data pointer 1 to the right. So I'm not changing what's storing my looping variable, I'm changing what's going to store my data, right? Which is here. Then at the end of the loop, I'm going to go back to the previous data pointer, which is going to move us from essentially here, or from this here to here. And then I'm going to subtract 1. What that is going to do is say, okay, we have 5 here in our first loop. Then every time we add 13, we'll subtract 1 from 5. And when we get to the point where this first data pointer is equal to 0, this loop will stop running and we'll print the value with a period. So let's look at this and we can see, I don't think I saved this properly actually. Oops, I need to move my data pointer over 1. When we do that, we get the character A. So the reason we didn't print anything the first time was because I didn't move the data pointer to the data value after I ended the loop, which meant it was still at what was telling us how many times to loop, which obviously was going to be 0 because we stopped. So when we moved it over to the right one, we got the character A. So this is how you kind of generate one character, right? You could do 65 plus signs if you wanted to make the character A. I mean, that's not really the best approach to doing this. The best approach would be to find the lowest 2 numbers you can use that multiply together to equal the number that you want. And if you wanted to do, say, like make it a little bit easier on yourself and multiply 6 10 times and then add 5, you could do that, right? So you could change this so that we have, what is this, 5? We can make this 10. So I'll copy this. So let's make this 10 like this, and then inside here we'll go 5, or we'll go 6 actually, I guess, which is that. So 1, 1, 2, 3, 4, 5, 6. Okay. And then after we move the data pointer, we'll add 5 to it. So 1, 2, 3, 4, 5, like that. And then print it. Oh, didn't mean to do that. And then print it, and we still get the character A. So that's how that works. So if we want to make hello world, we need to find a way that we can generate hello and then world. So I mean, I'm kind of going to leave that to you guys because I feel like it's going to be pretty boring if you guys just watch me do this. But let's do an example of getting some user input and then just printing that out. So let's do a comma and then let's do a dot and let's run this and see what happens. We can see we get the cursor blinking. Let's do the character, say B, and you can see that it just simply outputs the character B, right? And then ends the program. So if we wanted, what we could do is actually output, and then we could say move the data pointer over 1. We could add 5 to some value and then output that. And let's see what that looks like. Let's add some character R. We can see when we add R, then we print 5 directly after. It doesn't do anything, right? And that's what we get. Now, what happens if we don't print after we get the input? Let's look at it. So if we go R, you can see that it just immediately prints this unknown character, which is ASCII 5. Because it didn't print the character that we just inputted that was stored in data pointer 1. So that's the way that this works, right? And if we wanted to move over like 2 data pointers, or we wanted to move over 10 data pointers, we could do that in a loop too. So if we wanted to move, say, 5 data pointers, we could do plus, plus, plus. We could say, all right, actually this one will be complicated because we're going to have to go, if we move over 5, we're going to have to go back 5 to modify this initial counting variable. But I hope this gave you guys enough examples because I'm not going to do that one, so that you're confident in being able to use this. So I don't know. I think this is a fun language. I think it's cool. I like messing with stuff like this just because it kind of tests your brain. And I mean, look at the name of the language, right? It's not meant to be like, I don't know, fun, but it's not really meant to be useful. It's just meant to be like, can you figure out how to do some stuff? So a challenge for you guys, and I would, say this, is try to make it so you can have some input and then have the program do something according to your input. So maybe based on the number that it goes in, it's going to loop that many times and add some numbers together or something like that. See if you could figure out how to add 2 numbers. That's not very easy, right? How do you add 2 things? We can't just add with a plus addition. Like if I have 2 memories stored, 2 pointers or 2 different things stored in 2 cells, how can I add those 2 cells together into another cell? Well, the idea behind that would be, let's just, increment pointer 3. So if we have cell 1 and 2 with the values, let's increment point 3 so that it has all the values from point 1. So add that many times, and then we'll add all the values from point 2 to it, and that should give us the sum of cell 1 and cell 2. So small problems like that become difficult. I think it's fun. Let me know what you think of the language, and I hope you enjoyed this definitely long tutorial, but hopefully useful. So anyways, that has been it. I hope you enjoyed. Leave a like if you did, subscribe, and I will talk to you guys in another video.